Hey guys, welcome to the very first video in my data structures YouTube series. In this video, we're going to be covering linked lists, which is a fundamental data structure used in computer science. So with that in mind, let's get right into it. All right, so the first question to ask is, what are linked lists? Well, linked lists, as you may have guessed, are a type of list that works a little bit differently. They're made up of nodes. So actually, let me write that down right here. Made of nodes. And these nodes we'll get into a little bit later, but these nodes are used kind of to contain the elements of the list and then connect them in order to create the list as a whole. So again, we'll go into more detail about that, but for now, just understand they're made up of nodes. Second of all, something important that a linked list must have is it must contain a pointer to the first node in the list. And this is called the head node. So I can write this down here and say contains a pointer to the first node. And then I'll just put in brackets head. So this is important because once you see how nodes are made up, you will see how a pointer to the head will allow you to have access to all elements within the list by simply having that one pointer. This saves space and it creates a kind of string, or not a string, but maybe a path that you can move through the nodes in order to access the rest of the list, hence the linked aspect of these nodes, or of the list, I should say. So let's talk more about nodes. So let me scroll down here. Whoops, let me get some space here. Let's just write node, or nodes, I should say. So the nodes have two attributes. The first one is the value. Actually, you know what? I'm going to draw out kind of a visualization of a node first, and then we'll get onto the two attributes that it has. So I like to draw it as a little rectangle, or just a box, I should say, that's split in two. And the first box is going to be the value. So let's just say value there. And the second box is, well, okay, these boxes represent the attributes of, let's say, the class you are going to write, or the object you are going to write in code. So the first element or first attribute would be the value, and the second attribute would be called next. And next is the pointer to the next node, the next node that I guess would come after that node in the list. So let's say you had a linked list containing 1, 2, 3 in that order. The node 1, its next value will point to the node containing the element, or containing the value 2. And again, we'll see this very clearly once I illustrate these for you guys. But for the value, let's just say, I don't know, we can say 1. And next, well, when we instantiate the nodes, we generally instantiate the next initially to none, or the null value, or whatever you're doing in your, or I guess it depends on which language you're using. But yeah, we're just going to say none. I use Python, so that'll make sense. But yeah, so let me just kind of describe these a little bit for you. So value, again, is just the value to hold. The value to hold. Oh, my writing is kind of slanting. And next is just the pointer to the next node. It's a little bit connected there, but that's okay. And that's essentially it. Nodes are very basic, and that's partially why I was starting off with linked lists, because as a data structure, conceptually, they're very simplistic, very easy to implement, and as a result, very easy to understand. So I thought it was a good place to start. But yeah, these are nodes. These are what make up linked lists, and these are what contain the elements in the list. So now let's visualize a linked list itself. Yeah, I see that up there. That's bothering me. I'll scroll down a little bit more. But linked lists visualized. Perfect. So let me draw out a couple nodes, because as we said earlier, linked lists are made up of nodes. So let's just do a couple rectangles. I'm going to make them a little bit smaller just because I don't want to use up too much space if I'm drawing lots. So I'm going to have the linked list be 3 elements long. We're going to cut them in half there, just like that. And we can use our example 1, 2, 3. just like that, where the next will point to the next node in the list. Now, something important to keep in mind, by the way, is that the next pointer does not point to the value in the next node. It points to the node as a whole. All right, and we'll see that when we look at the code just after this. But yeah, it's very important. So you would, if you wanted to, let's say you were starting at the head. By the way, this is the head that I was talking about. The very first node in the list is called the head, just like that. And every linked list will have a pointer right to the start there. And because, actually it's very easy to see now, through the first node here, we can access any node in the list. So if we want to access 2, well, we start at 1 and use next to get the node here. If we want to access 3, well, we start at 1, use next, and use next again. And then we've got 3. Let's say we want to access something like 4. Well, we'll start at 1. Is this 4? Nope. Next one, is this 4? Nope. Next one, is this 4? Nope. Well, the next one is a null value or a none. So looks like we're at the end of the list. Sorry, 4 is not in this list. And that's basically it. Linked lists are very simplistic and very easy to use. And that's essentially the gist of how they work. So that through that head value, we can access every value, or every node in the list, I should say. And yeah, there are different types of lists where they might have pointers to like the start or the end. The start and the end might be connected. Various types of linked lists, which maybe we'll talk about a couple of them in the end just to kind of enlighten you to the fact that they exist. But in terms of going in depth, we're really just going to be talking about the standard singly linked list, which is what this is called because there is a single link between nodes and you can only really move in one direction. But that's it. That's essentially how a linked list works. You just start at the start, you work your way through. You can add elements to, or nodes, I should say, to the start, to the end. It really depends on how you need it implemented, but we'll go into a code example right after this. All right, so this is my implementation of a linked list in Python. It's pretty basic, pretty straightforward. The linked list itself only has 2 functions, inserting and deleting, which we'll get to in a second. But let's start at the top. So the node class, as I mentioned in the previous, sections, only has its two attributes, value and next. Value, of course, is being set to the value we want the node to hold, and next, at the time of being instantiated, has not yet been added to a list or anything like that, so its next value will be none. Same thing goes for the linked list. When we instantiate it, we are instantiating an empty linked list, so its head node is none because it has nothing at the start of the list. But that's kind of where inserting comes into play. So this insertion function just adds a value to the end of the list. I did that partially because I could replicate the append function commonly used in Python. And essentially how it works is just we check if the node, or if the nodes in the list, actually I guess we're not checking if the nodes in the list, but we're looping through the nodes in the list until we find the end of the list. And once we have found that node at the end, we say that that node's next value will point to the new node. And that's essentially adding it to the end of the list because all we need is pointers, right? If you remember the diagrams. And that's that. Same thing for the deletion function, or the delete function, I should say. This function just removes a value from the end of the list. Again, it might not be entirely practical for your implementation of the linked list or for your application of the linked list, but it's just meant to kind of illustrate looping through the list and traversing it until you get to the end. Once we found the end, great, let's remove it, or great, let's add it. Depends on which function you're using. But that's it. The functions are relatively straightforward. This code will be linked in the description if you want to take a look at it yourself, run it yourself, whatever. You can mess around with linked lists all you want. And yeah, that's that. So finally, we're going to talk about a couple linked list variations. So I've used linked lists throughout my time as a computer science student and a couple times throughout my time as programming. But there are a couple variations to the standard linked list that might be useful to someone who's looking to use something like this in their program. So the first one I kind of want to demonstrate is called a doubly linked list. So the ones we were looking at initially in the earlier diagrams were called singly linked lists because there is one link between nodes. A doubly linked list looks a little something like this, where we have our node with 3 sections instead of 2. Just like this. And we're going to have none here, and then I guess I should have left a little bit more room, but I can just say none here. So let's say we have our 1, 2, 3. Well, we have now value, we have next, and we have previous. And previous is, of course, a pointer to the node before it. So let's say we have, let's say, value, next. Let me clean it up like this. Previous and next. VPN, huh? Anyways, so previous might point to something. Actually, let me put it down this way. Previous will go this way. Next will go this way. This one's previous will go this way. Next will go this way. Previous will go this way. And next will go this way. So why might someone want to use this? Well, if they need to go forwards and backwards when traversing lists, or if they don't necessarily want to start by having a pointer at the head, whatever. The only downside to this is now you have to use more memory to constantly store next and previous nodes, or sorry, next and previous pointers for each node. But if memory is not an issue for you, then go ahead, use it. It just makes it easier to work with. So that is the first type of linked list variation. We'll go into the next one right now. All right, the second linked list variation that I've used and found particularly useful is called a circular or cyclical linked list, where it's essentially just a cycle of nodes. So you'll have something like this. Let me kind of draw it in a bit of a triangle pattern here. Whoops. Something like this. So we can say 1, 2, 3. Ooh, that was a bad 3. 3, and we just have our pointers going around like this. And that's essentially it. You're just linking up nodes in a circular pattern, so once you get to the end or the tail of the linked list, you go right back to the head. It's pretty straightforward. It's sometimes useful to use. You don't have to use it. And those are kind of the 3 linked list variations that I've personally used. I'm sure there's plenty of other variations that someone could create that all have their variable or varied uses from time to time. But yeah, that's been my video on linked lists. I hope you guys enjoyed it. If you did, leave a like, comment for future videos that you might like to see. I'll have a link to my Discord down below. It's generally used as a help server, but I don't know how many people in the server will know much about data structures or computer science in general, so if you want to just pop in to talk, that's cool too. But yeah, I hope you guys enjoyed. What did I say? Like, comment, subscribe, and yeah, I'll see you in the next one. See ya.